What questions do you have? Things are going all right? All ready for the exam on Friday? We'll talk a little bit more about it at the end of class today, but let's go ahead and finish up our graphs of other trig functions. And like I said, well, then we'll chat about exam stuff a little bit. So last time we went through what the basic shapes of tangent, cotangent, secant, and cosecant look like. So let's use this page here to summarize important information on each of these functions. So for tangent, again, what I think is easiest to remember for things like domain and intercepts is remember that your tangent is sine over cosine. And then if you're looking for the domain, what things can go wrong for your domain? What do we need to make sure it doesn't happen? Yeah, the denominator is not 0, right? Make sure we don't have the cosine equal to 0. So as far as the domain purposes for us, then we're going to have what can't x be? What makes cosine equal to 0? Pi over 2 and 3 pi over 2 and 5 pi over 2, right? The odd multiples of pi over 2, right? So the way we typically write that, so I don't have to try to do some confusing interval notation, is that x can't be equal to pi over 2 plus n pi, right? For every one of those x coordinates, of those x values, what do you see on the graph? What kind of thing pops up on the graph at every one of those things that we can't plug in for x? An asymptote, right? We had a vertical asymptote for each of those. For the range, remember what the tangent graph looks like? How's the tangent graph look? It goes like that, right? So what's the range going to be? Any y values that we don't hit? So the range is negative infinity to infinity. Good. Where did it cross the y-axis? It's 0, right? Because we put in 0 for x, we'll get 0 out, right? So the y-intercept will be 0, 0. Where does it cross the x-axis? When is the fraction equal to 0? When the numerator is equal to 0, right? So where is sine equal to 0? Pi and 2 pi and 0 and negative pi and negative 2 pi, right? So all the multiples of pi. So the x-intercepts here would be multiples of pi comma 0. And then finally, how long does it take for the tangent graph to repeat? Pi, good. So those are the important pieces of information for tangent. Can't plug in odd multiples of pi over 2. Range is all real numbers. Crosses the y-axis at the origin. Crosses the x-axis every multiple of pi, and the period is pi. Cotangent, of course, is reciprocal of tangent. So what issues are we going to have with the domain here? What can't x be? Pi. Yeah, pi or 2 pi or 0 or negative pi, negative 2 pi. So here x can't be the multiples of pi. And that's exactly where we'll have asymptotes again, right? What does cotangent look like? Well, tangent went this way. What does cotangent do? The other way, right? So range here is also going to be negative infinity to infinity. Yep, all real numbers again. Right? You didn't get one of these last time, did you? Where does the cotangent cross the y-axis? What happens when you put in 0 for cotangent? What do you get? You get an asymptote, right? So there isn't one, right? There is no y-intercept for cotangent. Where does it cross the x-axis? Well, it crosses the x-axis the same place that cosine does. When does that happen? Pi over 2, 3 pi over 2, 5 pi over 2, all those odd multiples of pi over 2 again, right? And what was its period? Pi. Good. All right. All right, so let's collect secant and cosecant, and then do a couple of examples of shifting things again with these graphs. For secant is 1 over cosine. So again, we need to worry about where cosine is 0, and that again is the odd multiples of pi over 2. How about the range for this one? It's a little bit different, right? Secant looks like what? There's like a U shape up here and one down here, and then it repeats, right? What was missing in the middle? What doesn't it hit? -1 to 1 is what doesn't get hit, right? So this is going to be negative infinity up to -1 and 1 to infinity. We actually do hit -1 and 1, right? I can get 1 out of cosine, and I can get -1 out of cosine, so I really do hit those values. But everything else is going to be bigger than 1 or less than -1. Y-intercept, if we put in 0 for x, what do we get out for y? Cosine of 0 is equal to 1, so we get 1. So the y-intercept is 0, 1. Does secant ever cross the x-axis? No. So there aren't any x-intercepts. And what was its period? 2 pi. Good. That okay? And then for cosecant, just to finish this off, what can't we plug in for x here? What makes the sign 0? Multiples of pi, good. How about its range? Any different range for cosecant as there was for secant? Nope, same exact range. What happens when you put in 0 for x this time? What do you get? Yeah, you get a 0 in the denominator, right? So is there a y-intercept here? No. In fact, there's a asymptote at x equal to 0, right? Does the cosecant ever cross the x-axis? No. And its period is also 2 pi. Oops. So this, again, is just gathering important information for these. So let's see if we can do a couple of examples here. Notice that these look a lot like the problems that you were asked for sines and cosines. We just now have it for tangent and cotangent and secant and cosecant. So remember when we had sine or cosine, when we asked for the period, how do we find the period for sine or cosine when we had something other than just an x on the inside? What did you do? When we asked for the period? 2 pi divided by the coefficient on the x, right? You're going to do the exact same thing here, but I just need to make sure I use the correct period. What's the period for tangent? Pi, not 2 pi, right? So in this case, if you want to find the period, we'll do pi divided by 2/3, which gives us 3 pi over 2. How did we find the phase shift? What did we do? Set solve for x. Yeah, set the inside equal to 0 and solve for x, right? We're going to do the exact same thing here. Set it equal to 0 and solve. So we'll multiply by 3/2 on both sides, and so we'll get x is equal to 3 pi over 8. And again, since this is positive, which way does the graph get shifted? To the right, right? Remember that when we do this solving, the positive actually tells us we go to the right. If we were negative, we actually go to the left. That okay? What do you think we would do for this next example that I have here to find the period and the phase shift? What do you think you would do? Divide 2 pi by d on pi over 8. Good. And why did you use 2 pi in this case? That's the period, right? That is the period for the secant function, right? The period is 2 pi, so I'll do 2 pi divided by pi over 8. Exactly like what we did for sine and cosine. Not any different at all. It's the exact same thing that we did, right? What do we get? 16 when we do that? For phase shift, yeah, perfect. So what's in parentheses equal to 0. We'll subtract the pi over 4 over, multiply by 8 over pi, and we should get negative 2. Oops, sorry. Yeah, negative 2. 8's on top. I just almost thought it was a half. Get x is equal to negative 2 in that case. And the pi's will cancel when you multiply by 8 over pi. Which way is it going to move then? Left. Remember the phase shift, we actually keep the sign in there, right? We'll make it positive if it's going to the right and negative if it's going to the left. That is not any different than what we just did for sine and cosine, is it? Literally the same process. The only difference is the fact for tangent and cotangent, start with a pi instead of a 2 pi. Literally the only thing that's different. Okay? And that's true when we do the graphs. The only thing that's going to be different from the process that we use for the graphs is we would use pi rather than 2 pi for tangent and cotangent. Otherwise, we'll approach the graphing problems just like what we did for sine and cosine. Okay? So let's do an example. We'll start with a cotangent graph. So again, just to remind, our cotangent has asymptotes where the sine crosses the x-axis. So we'll get vertical asymptotes at all the multiples of pi. And it'll cross the x-axis everywhere that the cosine graph crosses the x-axis. And then again, it goes down this way. And like I've mentioned before, I'm not looking for perfection. I just want general idea of what in the world's going on with these. If you want a pretty looking graph, use graphing utility. Use your calculator, use a computer. Or if you're an art student, great, go ahead and make a pretty looking graph. But I guarantee you the graphs that I'm going to draw are not going to be pretty. They'll be functional, but they won't be pretty. But that's what cotangent looks like generally, yes? To start with, that's the base graph. Tell me some types of transformations that are going to happen. There should be three that you should be able to tell me here. What three types of graphs? What three types of transformations are going to happen here? What's going to change?
Graph's going up by 1.
Say it again.
The graph's going up by 1.
It's going to go up by 1, right? That's the one out in front. What else?
It's going to be shifted to the right.
Yep, it's going to go right. Yep, I agree. And what else? What else is going to change? The period is going to change, right? Is that 3? Right? What is the new period, in fact? Pi over 3. Good. All right, we'll take the original period as pi divided by 3. For our phase shift, well, if I'm going to forget I originally forgot a letter there. If I'm going to forget the letter, I'd rather forget the T than a different one. Phase shift here, again, we'll set the inside equal to 0. Get pi over 6. And then our vertical shift will be up 1. And again, on your exam, you will have to do a sine or a cosine. That'll be 1. It'll be 1, right? And it will either be sine or cosine for the shifting for this exam. Okay. The first 4 parts are going to be identify the amplitude, identify the period, identify the phase shift, identify the vertical shift. Okay. That will be the first 4 parts to write those out. And then it'll be sketch the graph. All right. So, how do we change the period again? What's the easy way to do it? Well, the period was originally pi, so we'll change this pi to a pi over 3. If I change that to pi over 3, halfway in the middle is pi over 6. Good. And this will be, adjust accordingly. This will be pi over 2. Oh, yeah, well, this will be 2 pi over 3. This will be 5 pi over 6. And then likewise around the other side. I'm just dividing all of the x coordinates by that 3 that's on the x. That's all that does, right? Just changes it. For the phase shift, are we going to go right or left? Right. Everything's going to go right pi over 6, right? And if we need to draw a different set of axes, and maybe I'll do that just so I don't have an ugly graph. Try to make it look a little bit nicer. Everything's going to go right pi over 6, right? So all of your asymptotes will go right pi over 6, and all of your x-intercepts will go over right pi over 6, right? So if this is pi over 6 here, I'll have an asymptote here. And you're welcome to draw it on the same set of axes. I'm just trying to make it so I don't have so many lines on the same set of axes. But basically, all of those asymptotes are going to get shifted a click to the right, right? One of the pi over 6 units to the right. And all of your x-intercepts will get shifted a pi over 6 to the right. So they'll end up there. So this takes care of your phase shift. And then what happens? Yeah, everything goes up 1, right? Does that change the asymptotes, by the way, if you shift up 1? No. The asymptotes are infinitely long vertical lines, right? So if you shift up or down, it doesn't change the asymptotes at all, right? So as our last step here, we'll have this goes up to 1, and that That goes up to 1. That goes up to 1. And so on. Again, I'm not looking for perfection. I'm looking for that you understand the general idea. Yes.
So the asymptotes do move with the shift.
The horizontal shift, the asymptotes move, but they don't move when you do a vertical shift. That one okay? Let's do one more. I think there's one more in here, isn't there? Hey, look at that. There is one more. So surprised. Again, we got 3 things going on, right? You're going to move down to, there's some sort of phase shift that'll go to the left, and there's a period change, right? You agree with that? Okay. What will the new period be? 2. Good. How did you find that? Good. 2 pi divided by pi. That's exactly right. And I don't understand why. There we go. I guess my finger, I like the finger better than the pen. The period of cosecant starts out at 2 pi. We divide by the coefficient on the x, which is pi, so we get 2. Does that make sense? How do we find the phase shift again? Set the inside equal to 0, right? So we'll subtract pi over 6 and then divide by pi, so we'll get negative a sixth. So which way is the graph going to move? Left. Good. And then finally, for your vertical shift, down 2. Good. How does cosecant look to start with? Where are the asymptotes for cosecant? Yep, at 0, in pi, in 2 pi, negative pi, negative 2 pi. All those places where sine is equal to 0, right? We know it bottoms out at 1 and tops out at negative 1 on those alternating, right? Got an alternating kind of U-shape up, U-shape down, U-shape up, U-shape down. So it's up over here and down over here and up over here. Matches up this way. That's our base graph. Okay. Pardon me. Again, the period started out to be 2 pi. What is it now? 2, right? So it's going to change that 2 pi to a 2, which means it changes pi to 1. Basically, we're just dividing out the pi, right? Whatever that coefficient is on the x, you're just dividing the x's by that. That okay? Now everything's going to go left by a sixth, right? Well, my units are now, my tick marks here are now a half, so I'll go a third of the way over. I don't know why I decided to draw this one on the same set of axes as opposed to new axes, but move my asymptotes over a little bit to the left. Again, if you prefer to draw it on a different set of axes, that's fine. I just decided to do it on the same ones because I was being lazy. All of your other points will also get shifted over a little bit, right? I just did the asymptotes as a kind of a helping lines, right? We're going to go left to 6 and down 2, right? I'm going to do both of those at the same time because I can move over and down at the same time if I want to, right? Left a 6 and down 2. So that point that's at 1 will be at -1. It'll be over and down. This one is over a little bit and down at -3. Over a little bit and down at -1 again. This will be down at -3 and over a little bit. Over a little bit and down to -3. Over a little bit and down to -1. So we get the same shape. Just moved over and down. I don't know why I decided to put arrows on that one. This is why I drew the previous one on a different set of axes, right? It looks ugly. It's a lot of lines going on. But do you get the idea of what's going on here? I hope. Again, like I said, on your graph part, don't spend 15 minutes trying to make the graph perfect. Okay? I just want to see that you understand the idea. I'm not looking for perfection. Okay? So what do I mean by that? I want to make sure that your scale is right for vertical and horizontal. And get your top bottom points right. Because you're going to do sine or cosine, right? So there's a top out and bottom out based on the amplitude. Get those right. Get your middle points right. Where do the x-intercepts get moved to? Okay? So if you can figure out where it tops out, bottoms out, figure out where the middle is, you should be good. Then you just know what sine or cosine both go like that, right? At that point, you're just playing connect the dots. Okay? Not looking for perfection. Looking for the right idea. Okay? And again, like I mentioned, first 4 parts will be literally just writing the numbers down for me. What is the amplitude? What is the period? What is the phase shift? What is the vertical shift? And that's not even part of the graphing part, just literally getting those numbers down. That'll be half the problem. Okay? Any questions on this one at all? Pardon me. So as far as the exam goes, there will be 2 parts to it. There'll be a non-calculator part. So your non-calculator part will involve 2 things. One, can you give me exact values of the trig functions without your calculator? So sine of like 7 pi over 6 or tangent of -2 pi over 3, those kinds of things. That's what I mean by doing the exact values, right? Using reference angle ideas. The other piece is, can you sketch me a basic trig function? Not with any transformations. Can you give me a basic trig function? So we have 6 of them in the graph, right? Can you sketch 2 of them? Or 2 of the 6? Okay.
And that's like the basic one, or like
Just literally the basic one. So you want to, like what we did for tangent, cotangent, secant, cosecant, the basic ones, and sine and cosine. So I will give you a blank set of axes. You'll need to put the scale on there for me, and then sketch the graph. Just a basic, not shifted. Okay. I'll say graph y equals sine, y equals cosine, tangent, cotangent, secant, or cosecant. Right. Just a basic one. Okay. No shifting. That'll be the non-calculator part. Okay. After that, there'll be a calculator part with the other stuff in it. Okay. So your graphing with the shifting one, you'll have your calculator. So if you've got a graphing calculator and want to check to make sure that your graph looks like what's coming up, that's perfectly fine. Okay. But there'll be a non-calculator part. And again, the reason why I do that, besides making sure that you know those exact values of the trig functions for those special angles, pardon me, goodness. We'll also want to make sure that we know those basic shapes of the sign, the basic shapes and the basic properties of the 6 trig functions, because those are important to know if you're trying to do analysis later on the trig functions. That's why I have you do that. All right. So your calculator part then will focus more on, like I said, let me see if I can pull up the review sheet real quick and you can see the types of problems that are on there. You know, if I would have been planned in advance, I would have had this pulled up already instead of. Anybody got any intermission music to play while I'm doing it? Jeopardy theme, something. Got Muzak going on in the background. All right, so. Whoa, that was bigger than I wanted it. There we go. All right, so you've got in those first parts there. These would be the kind. These would be the kind of ones. This one here, part number 3. That would be the kind of ones where you would be doing on a non-calculator part, being able to do those kind of values. And then notice we're at 5 and 6 here are your transformations. Say where it says cosine is a base graph or sine is a base graph. That would be something that would be fair game on the non-calculator part, not the transformations, but the base graph part, as well as tangent, cotangent, secant, and cosecant. Okay. We did conversions between radians and degrees, so that would be that would be on a calculator part. Okay. So that was the type of stuff that we did in that first section. We also in the first section talked about what? That's quite a few things, right? We did. Oh goodness, we did arc length of a sector, of arc length of a circle, right? We also did area of a sector. That's this number 8 type of problem here. We did linear and angular speed. That looks like that number 7 there. All that stuff was in that first section. Pardon me. We did some problems with angles of elevation, right? That's what those last couple of word problems there are. And then we did the transformations. And we also did the trig functions of general angles. So we had those ones where I gave you a ratio and then asked you to find the other 5 functions of the trig, values of the trig function at that point. So not unlike what we did for quiz questions, right? I gave you quizzes over the first 3 sections that we covered. The only thing we didn't, I think the only thing we didn't have a quiz over was the graphing stuff, right? Again, I know that 5.4 has some of the transformation stuff for the other 4. Your transformation problem on the exam will be sine or cosine. Any questions on that at all? Or any questions about the exam? This review sheet is longer than what an actual exam would be, by the way. For example, I've got 2 of them with transformations. You're only going to have 1. Yes. This is on Moodle. Yeah. If it's on Moodle, there's an answer key on Moodle as well. Any questions about that at all? Yeah.
So number 5, you said that would be like on the no calculator section.
The base graph.
Just the base graph.
Yeah, just the base graph.
Okay.
But the transformation part will be on the calculator section. Yep. I'll be around the rest of the. I got class at 11, but I'll be around the rest of the day till about 5. If you got questions today, and I'll be around tomorrow as well. Math Center is open, of course, today, tomorrow. Professional tutor is around tomorrow, for hours tomorrow. All those hours are posted on Moodle as well. All right. Well, knock off a little bit early, if that's okay with you. I can see that you're all torn up about it. All right. We'll see you Friday, if not before.